All right, yeah, thank you, Jordan. My name is Wang, and thanks all for coming to this session. And glad to meet you all in this historical and beautiful building. So a little bit of background. I know in the program it's called RoadCode because that's the fun name we come up with during the competition. We have a group of people hacking on the project. But after we get into the end of the competition, companies saw the potential of this product and see the value that we can have on the society. So they start make the naming more consistent with other products we're building at Ford. So now we call it Safety Insights, but it's really the same thing. Like we used to call it RoadCode, but now call it Safety Insights. So to start the presentation, just a very quick introduction about myself. I know there already a little bit introduction, but my name is Bo Wang, working as a mobility analytics manager at Ford, working on different mobility solutions. And just Safety Insights is one of the products we're building in our team. So Carl, do you want a quick introduction about yourself?
Yeah, I'll come get the
yeah, if you can come here.
I mean, the intro was thorough, but I'm working as the product owner for the Safety Insights product, which means I help kind of lead the team. That's developers, data scientists, designers, all working together to build out the new functionality within the product, figure out how we want to set the vision and move forward. And my background originally is in urban planning and data science, so this is sort of a perfect intersection of those two focuses. And I've worked on, similar to Bo, a variety of different mobility projects at Ford.
Yeah, thank you, Carl. So, so I also have a traffic safety background in my graduate study research. So, yes, to give you a little bit of background, people always ask me the question, like, Ford, why you are here? Like, why are you working on those things? Because we are known for car manufacturers. I want to talk a little bit back to the founder's vision of Henry Ford. When he started building Model Ts, he has a great vision that freedom of movement drives human progress. That's really what drives him building those cars. Is because of people have cars, people have access to education, to fresh food in grocery. You can see your loved ones in holidays, and that's really what's the founding principle of the company. But we know we couldn't deliver that anymore just by putting more cars on the roads, right? Because there are air pollution, there are more crashes on the roads. The streets are congested, so we know we need to come up with new innovative solution to help bring people from A to B, more than just giving them the cars. In this specific case, we want to bring other innovative data sets together, but not just to put the data together, because if data is just sitting there, it's not valuable. It's really how do we extract the insights and make it actionable to users. That's the key things we are trying to do on our product. And also, we want to empower the end user to make decisions, to make the streets and people safe. And also, Jordan just quickly went through the competition, but in our case, we start in the phase 1 about July last year. When we start on the competition, we literally had nothing to design for this product. We organize a meeting, we come into the room, we look at the whiteboard, said, let's brainstorm for what we can do for the competition. It's really fascinating to see people's imagination and all their creativities that all come together. So in phase 2, we start more refining our product, and we start building the mock-up designs. You can see the visualizations, the buttons. You can start seeing it's emerging. And we are really happy to we are part of the semi-finalists, competing with other very respectful competitors, teams. But in the phase 3, about earlier this year, we started putting together a product team with designers, developers, and also data scientists. We created this interdisciplinary team. You can see there are a lot of passion, entrepreneurship, and also just people believe the vision of saving people's life with the data we have available. So I really just want to take a moment to thank USDOT organizing this data competition, because if you look at all their questions they ask on the competition, it's really asking the right things and leading us towards the success. They have very strong thought leader in this area, and we really appreciate that as well. So that's enough background information, and Carl will come and to show you what's the product we built in this competition. Yeah.
Yeah, thanks, Bo. I'll just echo, the thanks to the US DOT. The competition was really a great forcing function for us to begin to think about a lot of things that probably would have taken a lot longer for us to get to, or just, it really forced us to be extremely focused in terms of how we built out the product. So it's been really helpful. There we go. So what you're seeing here is just a screenshot of our product, the tool. So it's a software web application that we built out. And so the focus of it is really bringing in novel data sources to build off of the foundation of transportation safety analysis to provide new insight around things like near misses that potentially have been kind of hidden as part of the analysis picture. So the way we think about our tool is there's really kind of three pillars of functionality. So the first one is kind of the foundation, which is just the ability to visualize all sorts of different data elements together within one tool. So you have the ability to have a map interface. You can filter down to different data elements, whether that's crash data or some of the other data sets that we're bringing in. You can look for specific subsets of crash types, different times, days of the week, months of year, things like that. You can filter by geography, all the different kind of slicing and dicing that's necessary to find a specific subset of data you're interested in. But visualizing data is only part of the picture, right? It can quickly become pretty overwhelming and doesn't really lend itself to decision making. So that's where the next few steps come in. So the second part is, looking at crash data, again, it's just kind of a bunch of points on a map, right? How do you know where the true problem areas are? Well, there's a lot of best practices already out there for how to identify hotspots and do this kind of analysis. So what we did in our tool is we automated the Highway Safety Manual's network screening algorithm so you can identify hotspots with a click of a button. So this is really helpful to move from that kind of overwhelming data visualization in the first step to where the true problem areas that I should focus on. And then again, finding a problem is only gets you so far. Obviously, the next question you're going to ask is, what can I do about this problem? How do I move to a solution? And so that's where the third step comes in, which is where we've actually brought in thousands of countermeasures from the CMF clearinghouse into our tool so that you're able to quickly filter and identify potential solutions that might make sense for the location that you're looking at. And so within this table, we actually dynamically calculate the predicted crash reduction and cost savings if you were to implement one of these countermeasures for a particular hotspot. So I touched on this briefly, but it's a really key point for us. So within the industry, if there are trusted approaches for how to do certain analysis, we think it's best not to recreate the wheel, right? We don't want to try to come up with our own new approach if there's already a trusted, tried and true approach out there or a source that people feel comfortable referencing. So a few of those are the Highway Safety Manual. I mentioned the network screening algorithm within there. We've worked with the US DOT. They pointed us to a lot of really good resources through the competition. And then the CMF clearinghouse as well, right? So there's a lot of existing research on thousands of countermeasures, how you can work with the CMFs to understand predicted crash reduction. We pull a lot of that information into the tool rather than trying, again, to recreate this. So quickly, I just wanted to touch on a few of the data elements that power our tool. So anytime you're doing transportation safety analysis, the core, kind of the foundation, is going to be your crash data and your infrastructure data, right? Those are necessities. You need to understand where are the roadways, what are the attributes of those roadways, and you need to understand where there are police-reported crash incidents, right? Those are kind of given. But where there's some new potential within the space is some of these more novel data sets. So those are in the middle there. So the cell phone data is an exciting one. So we're partnered with a third-party cell phone data provider that aggregates and anonymizes cell phone data to allow you to understand travel patterns and movement across any geographies. You can get a sense of vehicle volumes, pedestrian volumes, bicycle volumes. So they're inferring a lot of this movement data based on the cell phone movement signals as you're traversing across the city. They also can help you understand OD patterns, things like that, in the past have often been captured via surveys. You can now capture a lot of this data passively. And then the other really exciting data set from us at Ford is the connected vehicle data. So Ford currently, when I say connected vehicle data, I mean kind of your traditional telematics type of data. So Ford has over 3 million vehicles on the road today that have an embedded cellular modem within them that's activated and currently transmitting data back to Ford. So we operate entirely on a opt-in basis for our consumers. So you have to consent to having your modem activated, and each individual consumer gets a lot of benefit from doing that. They get early warnings for different kind of prognostics around their vehicle. And so we can take that data, again, aggregate it up and anonymize it and provide really rich insight that really wasn't before possible at this kind of scale. So you can think about things like harsh braking events, excessive acceleration, traction control events that can maybe be used to inform winter road maintenance or things like that. Forward collision warnings, driving with your seatbelt off, right? There's all sorts of different signals that we can capture off of vehicles that are potentially really rich and powerful that we can make available through our tool. So for those who have been kind of following the progress of the competition, I just wanted to give a quick update on kind of what we've been working on since the competition ended at the end of May, at the beginning of this past summer. So really our focus has been just talking with transportation professionals and learning what they like about our tool, what value they find in it, and what we could improve with the tool. So what are some new features, functionality, things that we could add to make the tool even more useful? So we've been having a lot of these conversations over the past 4 or 5 months since the competition ended. What we do is we start to look for patterns in all those conversations that we're having to identify the top priority or high value features that we should build into the tool next. So for us, that's really key. And I'm going to talk through some of the feedback that we've heard and how we're converting that into features within the tool. The reason I go through this is because this kind of user-centric design is really core to everything that we do within our product development at Ford. We don't just want to build things that we think are interesting or we think might be useful. We want to be really kind of deliberate in focusing on what people are telling us they need or they want within the applications so that we know that there's value. So one of the things that we heard from folks as we were talking to them was the countermeasure information is useful, but it can be a bit overwhelming to sift through thousands of potential solutions. So how can we think about a recommendation engine or some kind of way to filter through that information to make it a bit more useful? So what we did is we added in some smart filtering components so that if you're looking at, for example, a hotspot in a downtown urban core, we're not giving you countermeasures that are meant for a rural interstate or something like that, right? You can automatically filter some of that out. And then we also added in some manual filters. So you can, if you're looking for a specific subset of countermeasures, you can quickly sift through that. The next piece we heard is just additional filters for the data in general. People want to be able to slice and dice the data in every way imaginable, which makes sense. So what we did is we added in all sorts of different filters, time filters, area, jurisdiction, roadway, intersection, so you can really find that specific subset of data for your analysis that you're looking for. The next one was that we heard the ability to estimate ROI, the cost to implement different countermeasures, is a critical part of the calculus in determining what do we want to actually propose for improvements to our roadways. And so, we understood that this is not something that, we would be uniquely suited to develop, really robust or accurate estimates for every type of countermeasure, for every type of geography. That's really best suited for the local engineer who has the kind of intimate knowledge of, local labor costs, the specific roadway geometry, kind of what projects have come out in terms of costs in the past, all that kind of stuff. But what we could do is build out a calculator to help them reach that end result a bit easier. So you can see here there's the ability for the user to input their cost estimate for a countermeasure, the annual maintenance costs associated with that, and the life cycle length for that particular solution. And then what we do is we take those inputs as parameters and automatically calculate the cost savings, cost benefit ratio, and time of return so that the user doesn't have to go through all that number crunching themselves. They just can input the values and we provide the output. So the last one is that, initially when we built out the tool, you could select some crash data, some safety related data, run the hotspot analysis, and you would see the results on the map. Which was useful, but it required a lot of zooming in, zooming out, panning around the map to be able to find maybe a particular area that you're looking for. So what folks wanted to see was probably some kind of list view so that they could easily kind of see all of the hotspots that were generated. And so what we did is we added this hotspot list view feature. So the map view is still there, and you can still pan around and look at the different hotspots shown there in pink. But now you can actually scroll through the intersection and road segment hotspots. Maybe you find one that is of interest at an area of interest, and you can click on that details button on the far right, and it'll zoom you directly to that hotspot, so you don't need to go looking around the map searching for it endlessly. So those are just some examples of some things that we've heard from folks that we can add into the tool to make it more usable. Some other things we're thinking about is just building in some additional years of crash data for more robust analysis, allowing our users to save and restore their session so they don't have to go back in and choose specific, what were those filters I chose to find that, the spot I was looking at. You can just save it, restore your session. We're looking at different product flows or, kind of user flows. So right now I talked through kind of you can choose some crash data or safety data, find a hotspot, find a solution, right? That's kind of one flow. But we've heard that there's other potential entry points for people to do different sorts of analysis. So one would be area first, which means maybe there's a neighborhood or an area around a school that you're interested in doing just some subset analysis around, maybe a specific corridor of interest. We want to allow for that much easier through the tool. Again, there may be like a countermeasure first approach. What that means is I have funding for a specific solution, maybe rumble strips, maybe something else, right? Or maybe there's a solution I'm really comfortable with, and I know what the solution is. I just want to find where the optimal allocation of that solution is for maximum crash reduction within my region, right? It's the same general ingredients that are already in our tool, just allowing the user to interact with the tool in a different way. So we're thinking through some of those kind of things. Also new map views, so things like satellite view, street view. We're doing a lot of research into our own connected vehicle data to figure out how to best make that available through the tool so it provides insight but doesn't risk any privacy or PII or anything like that. Also some like tooltips just to provide quick explanations of how did we calculate something, what does this term mean, just for the ease of use within the tool. So this is going to be just a quick, about a 1-minute video. I'll just talk over it, but it kind of shows the tool in action so you can get a sense of kind of what it looks like. So you can see here you can add in crash data, filter down to whatever type you might be interested in. So here they're going to select bicycle, intersection, pedestrian crashes. The map quickly updates. You can also filter down by geography. So here we're going to choose a specific county of interest. We're going to go down to Wayne County, which is the Detroit, city of Detroit area. So you can see when you're zoomed out, the crashes are clustered together, but you can zoom in and the crash points break apart. You can click on an individual crash, get some information about it really, really easily. So here now we're running the hotspot algorithm. So you can see the hotspot list view just generated. It ran in a few seconds. The user is kind of scrolling through and they're going to choose a hotspot of interest. Click details, it'll zoom you right there. You can see the pink circles and lines, those are the hotspots. Here's the roadway layers. This is where the connected vehicle data and the cell phone data comes in. You can see it's shaded, kind of shown as like shaded road segments within the map to provide additional context around kind of what you're looking at for the hotspot there. So you can zoom in to a particular hotspot. You can see the countermeasures. And so you can search through, filter down to whatever ones you're interested in. Here they're searching for pedestrian, maybe choosing a couple of countermeasures that they may want to propose for funding for this particular hotspot. You can generate an automatic report that really succinctly summarizes the changes you're looking to make for the particular hotspot you're looking at. You can print it, share it out with your team, kind of take it out of the tool and bring it to hopefully try to get some funding for those projects. So this is the last slide. I just wanted to end on kind of what is next for us now that we're beyond the competition, starting to think about where do we go from here. So through the competition, I guess what you could say is we really built out like a prototype, like kind of really a very early first stage of our product. But since then, we've built out, I guess, what we would consider really our beta version of our product. It's a bit more robust now. We're ready to put it in the hands of people to actually start using it. So what we're going to be doing is in the next really week or so, actually, we're going to be providing logins and tool access to a small group of organizations around Southeast Michigan to begin with. So you can see some of them listed up here, some agencies that are interested in working with us. City of Detroit, the MPO in the region, which is SEMCOG, Wayne County, Oakland County, City of Ann Arbor. They've all expressed excitement and interest in using the tool. They're going to provide us some feedback. And I'll just mention that we're also really interested in talking with others. So the tool right now is really focused around Michigan, Southeast Michigan. in terms of the data that's powering it, but we're really interested to see if there's interest in what it would look like to bring the tool to some other markets as well. I'll just kind of point that out. We're starting to have some conversations with some other folks around that. And the website there at the bottom, safetyinsights.ford.com, feel free to check it out. Just provides a bit more information about the product and kind of what we're working on. We'd be happy to answer any questions about kind of what's next for us. So thanks again for listening in. I think we have time for some questions.
Questions for Bo and Cal here?
Yeah, I've got a question about the, so I notice in here you've got the near miss information. So I just want to know, could you talk a little bit about that? Where are you getting it from and how are you defining a near miss? Because I think that's probably, to me, that's the most data rich piece of this, is that it really, in just working with safety in general, the near miss stuff is really where you really get your insights from.
Yeah, good question. So that's really where the connected vehicle data comes in. So through our connected vehicle data, we're able to look at things that approximate, near miss type of behavior. So if you think about like a forward collision warning in a vehicle, right, that happens when the speed of your vehicle is moving too fast for the object or vehicle ahead of you. And if you don't take some corrective action, there's going to be a collision, right? You get a warning that your car either alerts you or beeps at you. You could consider those sort of near miss type of events, right? So that's one example of a signal that we are able to capture off of our vehicles at a pretty good scale to be able to provide some rich insight about not where any one individual event happened, but at sort of a road segment view. Hey, along this road segment, along here this kind of time distribution, there have been 20 or 30 forward collision warnings, right? So it kind of gives you a different, maybe they're not all manifesting in crash outcomes, but that's where you can actually begin to understand a bit more comprehensive look at transportation safety than just where there are events so serious that they were police reported, right? There's a lot of incidents that happen in vehicle that don't result in crashes, but are still very much safety related. So the forward collision warning is one example. A lane departure warning could be another example. A harsh brake event, so someone has slammed on their brakes and their ABS activates. That could be another example, right? There's all sorts of these kind of signals that we are currently capturing at a pretty good scale off of our vehicles, and we're beginning to look at how do we make that available and useful through the tool.
Other questions for Bo and Cal? All right, I have one question for you guys. So Ford has a long history, and Bo, you mentioned this, of going back to the founding of designing. So different parts of the organization are always designing things. What did you bring in as you were designing this for the user interface, and what were some of the key principles? You talked a lot about the feedback loop that you got to help fine-tune some of the metrics in there, but what else about the design that really are kind of the big principles for you?
Yeah, I'll take a start, and then Bo, feel free to add in. But so for us, it was really how do we take some of these like pretty technical concepts and make a tool that's user-friendly and useful and really usable. Like anyone can kind of go into it and get a sense of how I should interact with the tool. They don't need a super in-depth manual, or they don't need a even some of the things like automating the network screening algorithm, right? It's we still provide the information about how we calculate all of these kind of values, but you don't need to have the PhD necessarily to get still the same output. We're trying to kind of democratize a lot of the knowledge and research that's already been done, that's already out there, just make it more usable for folks. So we really wanted the tool to be something that you could really quickly and easily log in, use it. You don't need to download software. It's a web application. There's a lot of components that go into the design of the tool that make it really kind of user-friendly and usable. I don't know if there's anything else, but
yeah, definitely. I think Carl covers most of the things. Like user-centric, it's like we take that literally. Like we need to be very user-centric. Like Jordan mentioned, we don't want to create some tool. We think it's cool, it's useful, but nobody actually uses it. We put on the shelf. That's why we keep talking to users day to day, like to bothering them, to making sure this is something that is useful. And also the democracy of the power of big data and the machine learning algorithm to the average user is another principle. That's why I like the tagline of our tool is traffic safety simplified, because I know a lot of states, they don't have a lot of people trained to read the heavy safety manual, and it takes an advanced degree to do all kinds of complex analysis. But in this tool, we are very proud. We automated majority part of that network screening analysis. And you basically click a button, and we start running some of those, building the model process, and you can see the results in a couple of seconds. So that's of course, we are also working with Michigan State and Wayne State and other professors to improving algorithm, but that's the principle we take, is reducing all the complexity of the tool and algorithm, big data into very simple use, almost like minimalism approach to give power back to the user, yeah.
I wanted to ask a quick question. How are you guys planning to have maintenance of your tool?
Have
once,
maintenance? Is that
once you have your tool out there and it's being used, how is it going to be maintained? Do you look for the DOTs to maintain it, or are you going to have, are you guys going to maintain it? How's it going to be maintained?
Yeah, so the intention is this is going to be a product that we go to market with as Ford. And so we would be the ones maintaining the product, continuing to add new features to it, and working with any, public entity customers or partners that we may have to, if there's new data that's available, we can, work together to define a common data model so that that kind of data can be easily ingested into the tool. And there's not going to be a whole lot of, maintenance or legwork required on any user end to keep the tool alive. That would be something that we would work to maintain. And so we're still kind of defining exactly what that business model or go-to-market strategy would look like in terms of, is there a free version that's just available for anyone to kind of use with limited functionality, and then is there a paid version with some of the more premium data sources and functionality, and how do those kind of different structures potentially work? We're ironing out a lot of those details now, actually through the beta testing, doing a lot of learning about what are people really looking for in the tool, and how do we kind of refine our strategy from there. But yeah, in terms of maintenance, it's something that we as Ford envision we would continue to own and build out over time.
I don't want to go to my mind, but does Ford maintain a lot of software? I don't mean to be skeptical. I'm just curious. Is it a new model or something?
Yeah. So yes, Ford has experience building software applications, web applications. We have built and maintain our own global network. We have built and maintain our own database system within Ford. There's a lot. We have a very robust data science and IT organization that has a lot of experience doing this kind of work. This is a bit of a different, as Ford is investigating new initiatives in the mobility space, that's a little bit new compared to traditional car making and things like that. But in terms of building software and maintaining software, that's something that we certainly have experience around.
All right, let's thank both these guys. Great job.